Compare center and spread. Shape tells a story. Look past the average.
Welcome back to the estuary census. As we watch the populations out on the mudflats, we run into a practical question. Which statistical summary correctly describes an animal group? This dot plot shows measurements piling symmetrically around a middle point. Here, the mean and standard deviation excellently describe the group. But sometimes data trails off lopsidedly toward far-flung values. When this happens, the median and interquartile range stay steadier. You choose your summary to match the physical shape of the data. Picking the correct tool for the specific shape prevents false conclusions. Let's compare two groups of mussels on these rocks. We'll call them Team A and Team B. We want to find out which team has the greater spread and which center is appropriate to compare them. Team A, 4, 5, 6, 7, 8. Team B, 6, 6, 6, 6, 6. Both sets are symmetric, so the mean is the correct center. Both means equal 6, but Team A spread stretches from 4 to 8, while Team B stays at 6. Both sets share a mean of 6, yet Team A is far more spread out. Measuring both the center and the spread is necessary to fully understand a population. Moving to the shallows, we have a new comparison. Let's look at the counts of silverfish in dataset A versus dataset B. This number line trail tracks the fish for dataset A. The recorded values are 2, 3, 3, 4, and 20. Take a close look at how these numbers are grouped. What stands out? Dataset A has a single value sitting way out at 20. That is a large, high outlier, and it pulls the tail to the right, creating a heavily skewed shape. If we were to calculate the mean, that skew would pull the center artificially to the right, dragging it far away from the actual cluster where almost all the fish are swimming. The median and interquartile range resist the magnetic pull of outliers. They safely mark the true center inside the cluster. Because this distribution is skewed and lopsided, the median and IQR are the appropriate comparison tools here. Let's focus on measuring that spread. We have two new sets of data living in these kelp beds, set A and set B, and we need to compare their middle 50%. This diagram shows the first and third quartile boundaries for both sets. The interquartile range, or IQR, gives us a precise measurement of the spread between these boundaries. For set A, quartile 3 is 18 and quartile 1 is 10. We subtract 10 from 18, finding an IQR of 8. Moving to set B, quartile 3 is 15 and quartile 1 is 11. Subtracting 11 from 15 gives us an IQR of 4. Because 8 is greater than 4, set A clearly has the larger spread in its middle half. Calculating the IQR gives us a reliable, outlier-proof numerical measurement for exactly how widely a core population stretches. The visual shape of the data dictates your tool. If the measurements are lopsided or feature extreme outliers, you use the median and interquartile range. If the shape is perfectly symmetric without any outliers, you can safely rely on the mean and standard deviation. Mastering this choice is what allows us to responsibly compare messy, real-world data without being misled by a few unusual numbers. The next time you encounter a new set of data out in the wild, ask yourself, how do the centers and spreads compare?
Center, spread, and shape. Compare two data sets. A picture plus numbers.